For this unit, we are going to be talking about marginals. So to illustrate this, we're going to talk about the cost function, the revenue function, and the profit function. So those functions are going to be the cost, revenue, or profit from the production and sale of X items. Now we will define marginal cost. Marginal cost is going to be the approximate cost of producing X plus 1 items. To find the cost of producing X plus 1 items, this is going to be approximately equal to the cost of the item at a value X plus the marginal cost at that same value. Similarly, we can define the marginal revenue. This will be the approximate revenue from selling X plus Y items. This is R of X plus 1 is approximately equal to the revenue at the X value plus the derivative of R at that same value. Now we can also define the marginal profit. This is the approximate profit from the production and sale of X plus 1 items. This is going to be P of X plus 1 is approximately equal to P of X plus the derivative of that same X. Now let's put this all together and do an example. For Sunshine Motors, the weekly profit in dollars from selling X cars is P of X equals negative 0.006x cubed minus 0.2x squared plus 900x minus 1200. And currently 60 cars are sold weekly. What is the current weekly profit? For this, I just have to plug in 60 into the function and solve that. This equals $50,784 in profit. The next question says, what is the marginal profit when X equals 60? The marginal profit is a measure of slope at that point, and slope we know is derivative. So P prime of X is going to equal negative 0.018x squared minus 0.4x plus 900. Then I'm just going to plug in 60 into this equation, and this will equal $811.20. That is how the profit is changing when 60 cars are sold. Part C says to use the marginal profit to estimate the weekly profit if sales increase to 61 cars per week. Well, we learned at the beginning here that P of X plus 1 is just going to equal P of X plus P prime of X, or the derivative of P. So P of 61 is going to equal the profit function at 60 plus the derivative function at 60. Well, we already have these values, so it's $50,784 plus $811.20. So this is going to be $51,595.20. So if we sold a 61st car, this would be our profit. The next question says, to use the marginal profit to estimate the weekly profit if sales increase to 62 cars per week. We already figured out the profit for 60 cars, and then the change or the rate at which we're selling 60 cars. But now we want to see what the profit might be at 62 cars. So I need to add the $811.20 like I did in Part C. And then if I'm going to sell another car, I need to add another $811.20 because that is the rate. I'm going to sell 2 more at this rate. So this will be $52,406.40. Now, the question is, why are we doing this? To answer that question, let's look at this example. Suppose that an animal rescue organization is considering increasing its monthly production of public service announcements, also called PSAs, from 12 to 13. To estimate the resulting increase in costs, it would be reasonable to find the cost at 12, and then we also want to find the rate that it's changing at that same 12 PSAs. So let's first look at this red line, the bottom line. So looking at the function, here's the cost of 12 PSAs, and here's the cost of 13 PSAs. But if you're a member of this business, we don't know how much it costs to produce 13 of these PSAs until we've actually done it. So how do we project that? To do that, we're going to find the rate that 12 PSAs is changing. The rate is the slope. What is the slope at this point? Then we're going to add that slope to C of 12. That gets us C of 12 plus C prime of 12. So it's not the exact same value, but we get a close enough estimation of how much it would cost to produce that 13th PSA. The thing is, maybe that 13th PSA never gets produced. If we're part of that company, we're trying to figure out how much it would cost to get it produced. And that covers marginals for this unit.